In this video, we're going to kind of combine the last two lessons that we looked at, proportional relationships and solving proportions, and we're going to talk about direct variation. So direct variation is a specific relationship in which there is a constant ratio between all of the ordered pairs. Now, a ratio is just a fraction. The fraction that they're going to use is y over x, which, if you'll remember, in our proportional, non-proportional coloring, we looked at the ratio y over x to decide if a table was proportional or not. We wanted y over x to be the same, that's what it means by constant, between all of the ordered pairs. So y over x is the same. This constant ratio is called k. Again, if you remember in our quick color, we said that proportional relationships are so special that we give them a different letter for slope or rate of change, k. And that's what we call this ratio y over x. So k is y over x. Y over x must be the same for all of our ordered pairs. And the equation, which I hope you guys can tell from the equations in our proportional relationships here, instead of using an m, we're just using a k, and we know that it has to go to the origin, so that would be a plus 0, and y equals kx plus 0 is really just y equals kx. So the equation for direct variation is y equals kx. So looking at 1 through 4, we just want to identify if the we want to identify the constant of the ordered pairs below. This is the constant ratio, which is k. So we want to find k, which is y over x. Remember that in an ordered pair, we have x on the left and y on the right. So if I'm looking for y over x for all of my ordered pairs, I need 4 for the y value divided by 1. We need 8 for the y value divided by 2. We're looking at y over x, that would be 12 over 3. Y over x is 16 divided by 4. Well, 4 over 1 is 4. 8 over 2 is 4. 12 over 3 is 4. And 16 over 4 is 4. So I know that 4 is equal to k. Now that I know that, I want to write the equation that represents this relationship. So we have 4 equals k, and now we want to write y equals kx. So we have y equals 4x. In number 2, I'm going to look at all of the ratios, y over x. If those are all the same, then I'll know what k is. So I need y over x. That's the second number, y, divided by the first number, x. So this is 3 over negative 6. This is 2 over negative 4. This has an x value of 0. Remember back to the color sheet. When x is 0, since we can't divide by 0 in the denominator, we cross out that ordered pair. We're just going to skip it. And then we've got negative 1 divided by 2. 3 over negative 6 reduces to negative 1/2. 2 over negative 4 reduces to negative 1/2. And negative 1/2 is negative 1/2. So the constant ratio, k, is negative 1/2. Now that we know k, we can write the equation y equals kx. Instead of k, we're just going to put a negative 1/2. Looking at number 3 and 4, this is the same thing but from a table now instead of a list of ordered pairs, a set of ordered pairs. So we're looking at y divided by x, which is negative 8 divided by negative 12. That is negative 4 divided by negative 6. 0 divided by, x is 0, so we have to cross that one out because dividing by 0 is mathematically illegal. And now we've got 2 divided by 3, y divided by x. All of these things reduce to 2/3, so I know that the constant ratio, or the constant of variation k, is 2/3. Now that I know what k is, I can write the equation y equals kx. I'll just put 2/3 in place of k. We found k was 2/3 by dividing y over x and simplifying to 2/3. Then we wrote the equation of direct variation. This relationship was y equals 2/3 x. We just replaced 2/3 in place of k. Looking at number 4, we need y divided by x. So that's 12 divided by negative 4. That's 3 divided by negative 1. That's negative 9 divided by 3. Negative 15 is the y value divided by 5, the x value. All of these reduce to negative 3. Now that I know what k is, we can write y equals kx. We'll just put the value for k in place of k. So instead of y equals kx, we have y equals negative 3x. The second portion of these notes gives us an equation. We want to identify, does that equation show us direct variation? If yes, we're going to identify the constant of variation. We go back up here to the very top where we wrote the equation for direct variation. The equation for direct variation was y equals kx, which is exactly the same as the equation for a proportional relationship. So what we're really doing in that second part is deciding if the equation is proportional. Direct variation just means that it's proportional, that the relation is proportional. And remember, if it's proportional, this looks like y equals kx. However, if it's non-proportional looks like y equals mx plus b. So I'm going to have y equals mx plus b above the equation and y equals kx below it, just so I can compare very easily. This first equation looks like y equals kx. So I'm going to say yes. Now, the directions say if yes, we need to say what the constant of variation is, or k. The number in front of x is k, and the number in front of x here is 3, so I know that k is equal to 3. In number 6, I'm writing y equals mx plus b above the equation, and y equals kx below, just for an easy comparison. This equation looks like y equals kx. So yes, this is proportional. Yes, it shows direct variation. Now I need to decide what k is. K is the number in front of x, which is negative 4/5. In class, we're going to skip 7 and 8. Look at number 9. Number 9, I will write y equals mx plus b above the equation and y equals kx below, just for an easy comparison. This equation looks like y equals mx plus b. And y equals mx plus b is non-proportional, which means this is not direct variation. This is not direct variation because b isn't 0. B is -4. Looking at the last equation here, I'll have y equals mx plus b and y equals kx. I'm writing these down just to make the comparison very easy. This looks like y equals kx, but there's not a number in front of x. There's just a negative sign, which means, first, this is yes because it looks like y equals kx. And because there's still an x here, there is one x, and that one x is negative. So k is a -1. This is all the notes for the front of page 91. Flip to the back of page 91. Now we have some graphs, and we want to know if the graphs show direct variation. Direct variation just means that it is proportional. For a graph to be proportional, two things had to happen. We had to go through the origin, and it has to be linear. Remember that linear is not undefined. Number 14 goes through the origin. Number 14 is linear, which means yes, this is proportional. If it's proportional, or it does show direct variation, then we also need to identify the constant of variation. So I need k. K is y over x, which is really just rise over run. In the equation y equals kx, that's the k is in the same position as m in mx plus b. So they're both talking about the slope. So we need to find the slope of this graph. So I find two perfect points, 2 points that are on a crosshair, and I need the rise over the run. So this is a rise of 3 and a run of 2. And this is positive because the line goes up from left to right. 3 over 2 doesn't reduce, so I can leave my answer as k equals 3/2. Looking at number 15, this graph does not go through the origin, but it is linear. However, since it does not go through the origin, since it is not both going through the origin and linear, then this is no, not direct variation, or no, not proportional. If my answer is no here, I don't have to do anything else. Number 16, the line goes through the origin. The line is also linear. Since it goes through the origin and this is linear, then this is yes, it does show direct variation, or yes, it is proportional. So now we need to find k. Well, k is just rise over run. Here's a perfect point. There's a perfect point. The rise is 1. The run is 1, 2, 3, 4. And from left to right, this line goes down. So this is -1 over 4. Looking at number 17, this line does go through the origin, and it is linear, it's straight, but not undefined. So yes, this does show us direct variation. Yes, this is proportional. And K would tell us find the slope. Rise is 1, 2, 3. Run is 1, 2, 3. And 3 over 3 is the same as 1. So I'm going to say that K is equal to 1. And that is positive from left to right. This goes up. Looking at the last portion, this is where we really combine what we did yesterday with what we did the day before. We need to find missing values. So now I know that there is direct variation. Since there is direct variation, I know that there's a constant ratio K. That ratio is y over x. And I know that it has to be the same for all of the ordered pairs. So if I look at y over x, that would be negative 4 over 2. The y value over the x value. The y value, y, over the x value, negative 6. Now I know that because this is direct variation, that these fractions are the same. Since they're the same, if I want to know what y is, I can just solve this proportion. So I cross multiply. Negative 6 times negative 4. And then I multiply 2 times y. Negative 6 times negative 4 is 24. And 2 times y is 2y. To get y isolated, we divide by its coefficient 2 on both sides. 24 divided by 2 is 12. 2y divided by 2 is 1y. So I know that 12 is equal to y, or y equals 12 in number 18. Looking at number 19, to solve for the missing value x, I need to use the fact that I know that this is direct variation. That means that y over x is the same for both of those ordered pairs. So we have 16 over negative 4, or sorry, over 4. That's a normal positive 4. And then the other fraction is 24 over x. Cross multiplying, we'll have 4 times 24 and x times 16. X times 16 is 16x. 4 times 24 is 80 plus 16 is 96. To isolate x, we divide by its coefficient, 16. On the left, 16x divided by 16 is 1x. On the right, 96 divided by 16 is 6. So in number 19, we know that x is 6. Number 20, we need y over x, and we know that those are the same for both of these ordered pairs, which means y over 12 for the first ordered pair is the same or equal to 7 over 4 from the second ordered pair. To solve for the missing value, cross multiply 4 times y and 12 times 7. So now we have 4y equals 84. To get y by itself, we divide by its coefficient. 4y divided by 4 is 1y. 84 divided by 4 is 21. So I know in number 20 that y is 21. Now in 21, we've got x is the missing value, and I know that this is direct variation, so y over x is the same for both of those ordered pairs. So I have negative 16 over x is the same as 24 over 6 from the second ordered pair. So I can cross multiply 6 times negative 16 and x times 24. 6 times negative 16 is negative 96. And x times 24 is 24x. And now I can solve for x. I have, negative 96 equals 24x. So to isolate x, we divide by its coefficient 24 on both sides. On the left side, negative 96 divided by 24 is negative 4. And on the right side, 24x divided by 24 is 1x. (22) through 25 are a little bit different. In 22, I've got y equals 18 when x is 3. So instead of giving me an ordered pair, it's kind of giving me a word problem here. We know that y over x is the same for both of those ordered pairs. This is saying y is negative 18 and x is 3. So the numerator is negative 18 because that's where y is, and the denominator is 3 because that's where x is. This is equal to 30 is y is the numerator, so 30 is on top. And then I don't know what x is, so we can leave that as a variable. Now, to solve for x, we will cross multiply x times negative 18, 3 times 30. So we have negative 18x equals 90. Now we need to isolate x by dividing by its coefficient. So we divide by negative 18 on both sides. Negative 18x divided by negative 18 is 1x. 90 divided by negative 18 is negative 5. So number 22, x is negative 5. In number 23, we'll have y over x. I know that y over x is the same for both situations. This says y is 80, so 80 is in the numerator, whenever x is 32. So 32 must go in the denominator. It wants to know what is x when y is 100. So we cross multiply. X times 80 is 80x. 32 times 100 is 3,200. To isolate x or get it by itself, you need to divide by 80, its coefficient on both sides. Now x is 40. Looking at 24, to set this up, to find the missing value, and I know that this is direct variation, I need to use the fact that I know y over x is the same for both situations. Y over x for the first part is going to be 10 over negative 4. For the second part, I don't know what y is, but it tells me x is 12. Now I cross multiply to make a equation and solve. 12 times 10 is 120. Negative 4 times y is negative 4y. I'm going to divide by negative 4 on both sides. 120 divided by negative 4 is negative 30. Negative 4y divided by negative 4 is 1y. And the last problem here, it says if y is equal to negative 7 when x is equal to negative 28, find y when x is 20. I know this is direct variation, which means I know y over x is the same. So I'll have negative 7, a y value, over its x value, negative 28. I want to know what y is whenever x is 20. I know these are the same because this is direct variation. Now I can solve this proportion by cross multiplying. 20 times negative 7 is negative 140, and 28 times y is 28y. To get y all by itself, we'll divide by its coefficient. So we're dividing by 28 on both sides. Negative 140 divided by 28 is 5. 28y divided by 28 is 1y. So y is equal to 5. That is all of the notes for direct variation. Your homework assignment is identical to these parts except with different numbers. So the first portion of your homework looks like the first portion of the notes. The third portion of your homework looks like this. And the last portion of your homework looks like this. Same directions and everything. If you have questions about the content in this video or about the homework, please message me on Schoology, send me an email, or you can drop a comment on this video and I'll be glad to get back to you as soon as I can.